Yeah, Levi, erase that blob.
Oh, you caught me. I'm in the hallways of Harvard and working on a very complex math problem. I must be very smart.
You need...
But I'm gonna reject him at first and be mean to him about his passed away wife.
Those are your defenses from your rough childhood.
Right, but it's not my fault.
It's not your fault. Hey, it's not your fault.
Stop it.
Don't you know
Stop it.
that it's not your fault?
Stop. Oh!
Do you get it now?
Yes, all my problems are fixed.
That's all that it takes.
Then you make a movie about it. That was actually their relationship in real life at the time.
No way.
Oh no.
You know, I didn't realize that it was about a guy named Will Hunting. I thought it was like, hey, you're gonna go hunting? Here's Goodwill. I didn't know. I just didn't know.
You just didn't know. It's not your fault.
There was no way for me to know. Don't you see that?
I see that. I also see that every time you exhale, the breath goes out the eyeball holes of that mask and fogs up your glasses.
Well,
I really hope they can see it, but unlikely.
That's how lions work.
Oh, they breathe out of their eye holes?
Yeah, did you not know that?
I didn't know that, but it's not my fault.
What do you think about the two of us doing a sick dance break?
I feel pretty good. 1, 2, 3, go!
You've got to do better than that, Mr. Levi. Are you okay?
I'm okay, but my marker's not.
You're ruining the dance break. 7:30 to 9 p.m. Eastern Standard Time.
1, 2, 3, let's go. Whoa! Uh-oh, this is naked. There we go. There we go.
I like these intros. Well, Roby, the intro was live when we filmed it.
Yeah.
It's hard to film something that's not live.
Yes.
Well,
no. We made that film of my great-grandmother.
Oh, that's right.
Yeah.
Of her just lying there.
Yeah.
Because she's dead.
Yeah.
Right, I forgot about that. That was a dead recording.
Hi, Prod.
One of my favorite movies. Hey,
George
George is watching. Hello, George.
George.
Oh, man.
Should we tell him?
What do we tell him?
Well, nobody knows George.
George, we made a new intro video. I don't know if you were watching it. You can just go back to videos and click on it, and you'll see the beginning of it. But we're making lots of videos for Instagram, George. No one knows who George is except for us. Can we keep George a little secret?
Yes.
Great grandma.
Justine's watching. I gotta text the Discord. Everybody's watching. Why is everybody watching? What did we do?
Stop watching.
Yeah, this is only meant for like 8 people.
WH.
You piping Justine, piping Justine, or what? They're on Facebook. Piping?
No.
What?
Watch it, Prod.
Oh.
Here in the moment. Hello. Do you have questions for us?
I'm looking for general announcements. No announcements.
You didn't announce yet?
I'm gonna announce right now.
All right, you had a
We're
child.
having a baby, and it's nerdish.
On the stream.
Live birth.
No, I meant like we're teaching a baby, not like we're giving birth to a baby.
Oh, I thought we were doing the first thing.
Why would you say that? All right. Anyway.
Yeah.
Oh, we have a... Oh, no, that's you that just posted that.
Yeah, that was me. Sorry. Oh, you thought we had people that actually watched us and asked us questions?
Well, yeah. Oh, is that a jerk lump question from today?
I think we did that yesterday.
Yeah, we did.
Curious George. Yeah, that's right. You look like dried up snot, Prodanics.
Whoa.
It's getting pretty heated on our Discord.
Yeah. Put that heat into the questions.
Not Discord, that's Restream.
Yes, in the chat.
From them it's the chat, sorry.
Chat.
Yeah, okay. You guys gotta calm down. Just extinguish those flames. Because they're burning right now. And like General William Tecumseh Sherman's March to the Sea, there's a swath of destruction that someone's gonna have to pay for. And it ended up being the Union. It's really interesting. They did that scorched earth tactics during the Civil War. But of course, when the Union won, they had to repair it because it's their country again.
Classic Union.
But they had to win. They had to win the war. That was the important thing.
Yeah. It's always about winning the war, not how you do it.
I mean, people would argue that, yeah, that's the most important thing is winning the war.
That's how it feels.
What?
That's how it feels. I agree.
What feels? To win the war?
Oh, look at this. We got a question. I'm going to do the heck out of this question. Heyo. This question is from the Reddit SAT, by the way. How to do this problem with completing the square? You know, we can find the vertex, but how can I tell which one by completing the square?
Oh, I see. There we go. I remember this one.
Do you? Is this one of the main 10?
No, I think this is one of the ones that.
Like on a different test?
I don't know.
Should
I just
we not
remember
do it
this
then?
one. No. Let's do it.
Alright.
I think it'd be fun.
Aight.
I think it'd be fun. Yeah, +1. The vertex is going to be that, and it's going to be lifted up.
Oh.
Yeah, I get that.
Let's do it.
X +1, so that is -1. Leave.
All right.
All right,
So-
hey, knock it off, all you kids that are in front of computer screens across the country, and thus really should not have any real issue with each other.
We will take your fingers off of your bodies.
Justine! My neck.
All right.
Roby expert. My neck.
Transform.
Make it, you gonna do this one?
No.
No? I mean, I'll do it. I'll do it. Oh, this is excellent.
Well, you don't really need. You want more space to do some completing the square, right?
That's whatever you have right now is fine.
Yeah, but the person specifically asked for completing the square.
I'll complete the square. I will complete the crap out of that square. If it looked like this, Levi, if it looked like this, you know what I would do? I would do this. That's what I would do. We're talking about completing the square. So,
Got it.
what the, you didn't realize that?
Nope.
Okay. Someone on Reddit wanted to know how you could use completing the square to figure out what this equation would be in vertex form. So just a little reminder. Vertex form looks like this. Where A is like the normal A, it's like the leading coefficient in any form of quadratics, it's A. H comma K is the vertex. So once you see vertex form, you'll know what the vertex of the parabola is, and then you can line it up because all of these have different vertices. They're all quite different. So we have to turn y is equal to x squared plus 2x plus 2 into vertex form. And the hallmark of that is this thing right here. They made a square term in parentheses. It's a factor multiplied by itself. So the way to complete the square in this situation, forget about the fact that we have plus 2 right now. Focus on this. We have to create a square trinomial that has 2 as the middle coefficient. Gotta get some napkins here. No, they're towels. And just a reminder, in order to do something like that, let's say you had, here we go, like x squared plus 8x plus 16 is x plus 4 squared. And if we didn't know 16, we would say the middle term is 8, you divide that by 2, and that's how you get 4, and then you square that, and that's how you get 16. So the middle term you got to divide by 2. So divide by 2, that gets us 1, and then if you square it, that's what's supposed to go here. So we need to have a 1 there. So when I rewrite this thing, I'm just going to split it up from the 2. I'm going to have plus 1, plus 1. It's going to be fine. So y is equal to x squared plus 2x plus 1 plus 1. All right, I split up the 2 because I want a plus 1 here, because this is the square trinomial that I can simplify into something that looks like this. But I can't change it that we had plus 2 before, and it still needs to be equivalent to that. So now that I've got this right where I want it, I'm going to factor it into something that looks like this. So now it's in vertex form, which means the vertex is going to be -1, 1. And the parabola that has that, -1, 1, looks like it's going to be B. B has -1, 1. Now, a couple other ways that you could figure out that it is going to be B. They all have the same y-intercept. It's all 2, so that's fine. You could do a couple of things. You could try to factor and see if that would give you some zeros. In this case, we'd be finding two numbers that multiply to 2 and add to 2, and there are no such numbers. So you could also do the quadratic formula. If you have that on your calculator as a program, I strongly recommend that you get that because it'll do it very quickly for you. But another you could do is, I'm going to say, the discriminant. The discriminant tells you how many solutions there are going to be. So the discriminant in this case is b squared minus 4ac. And if I put in the values from this one, we have 2 squared minus 4 times 1 times 2. Minus 4ac, which is going to give us 4 minus 8, which is negative 4. If your discriminant has a negative value, that means there are no real solutions. So it should never cross the x-axis. And there are 2 of them that have that characteristic, which are C and B. So we can get rid of A and D because they have real solutions. Or derivate. Derivate, what does that mean? Differentiate, or take the derivative of. It's a calculus term. It's really fun. It takes a little while to learn. I could try to explain it, but that's not the point of this channel. But yes, you could do that in order to find the minimum. That's absolutely true. Let's see. Are there any other things you could do? Oh, yeah. Oh, geez. The vertex. Yeah, minus b over 2a. Yeah, so the vertex of any parabola has the form minus b over 2a. At least that's the x-coordinate of the vertex. So in this case, we have negative 2 over 2 times 1, which gives us negative 1. So our x-coordinate of our vertex needs to be negative 1. That gets rid of C. That gets rid of D. They have positive x-coordinates. A and B are still alive, but we already eliminated A. And if you want to find the y value, then you just plug that x value back into your formula. So I have x squared. So we have negative 1 squared plus 2 times negative 1 plus 2. Positive 1 minus 2 plus 2 is equal to 1. That is the y-coordinate. So again, we know our vertex is negative 1, comma 1, and only B has that as a vertex. Very exciting. We beat that problem to the ground. We could find the complex roots, but it's not going to help us with this. It's just going to help us in life. Because you'll be surprised how many times you're going to have to find complex roots of a quadratic in your daily life, especially if you live in a big city. I mean, if you walk around New York, people are finding complex roots.
Bert, are you okay?
What does FFT mean? For the win. Ah, yes, that's right. For tin. That's for you misspelled for the win. All right, Levi.
Yes, Bert.
I want you to do something for me. Can you do that? Very good. What does our Discord look like? Questions for stream. Nothing. Fast Fourier transform. Huh. I'll show you a fast Fourier transform. I just did it. You didn't see it. It was that fast. Whoa, you're so fast. I know.
That's what everybody tells you.
You think I don't know that? I wanted that.
No, you didn't.
You're right, I didn't. Where do you want to go?
What did you want from me?
I just want you to do something.
Okay.
The next problem, perhaps?
I can probably do that. If we have a next problem. Here in the moment. Do you have any questions for us? Before this moment, it's very important that you ask us questions, or figure out your questions so that you can ask us questions. Otherwise, we kind of just bumble around. Can you go over probability? Yes, Bird, we're going to go over probability. How does that sound?
That's good. It's pretty probable that we're going to do it, considering somebody asked us. Do you want to go for it?
Yes. Where should I start? Because probability is a very big thing.
Yeah, I start with just rolling a single die. Probability of a side, great. Probability of getting this or this. Probability of getting this and then this.
So or, and?
Yeah.
Like that type of thing?
Yep.
I'll get to that later. Okay. Start at Poisson. I'll start you at Poisson. All right. So, let's say you have a die, and it's a nice, normal, six-sided die. Something like this situation. Yeah? So you have a die. What grade is 18? Who knows? Okay, so obviously you have a couple different things. We have we have exactly 6 different rolls we can get. We can get a 1, we can get a 2, 3, 4, 5, or a 6. They each have a 1/6 chance or probability. So the probability, capital P is generally probability. the probability of the X event. So each of these has a 1 in 6 chance of happening. That probably makes a ton of sense if you know how dice work. And so if the question is, what is the probability? What is the probability of rolling a 3? Well, 3 has a 1/6 chance, so the probability is 1/6. What is the probability of rolling a 3 or a 4? Well, in that case, you would have either of these things happening. So if you have an or, this is a nice important rule. If you have or, that means add your probabilities. Add the probabilities. Probabilities. You're weird. Damn these unbiased dice. Damn them!
Careful.
What? That's fine.
Darn them all to heck.
Darn them. Darn the dice with your sewing kit. All dice are biased, though.
You know all dice are diced as well?
Yeah? You want to come up here and say that to their face?
All dice are diced.
Right. I like my bison diced.
Mm.
So, probability of 3 or 4, it's both of those. So you have a 2 in 6 probability, which is a 1 in 3 probability of one of those things happening, 3 or 4. Now, let's go to the other situation. If we say we want the probability, we're going to roll 2 dice now, or 1 dice 2 times. It doesn't really matter. The probability of getting a 3 and then a 4. So 3 and 4. So the first roll is a 3, the second roll is a 4. Okay? You have to have it in that order. So this is the first roll and second roll. This would be, when you have the word and, you have to multiply your probabilities, okay? Because you're going to, so the first event, these two events are unrelated, right? You roll, let's say we're rolling 1 die twice. So what is the chance we roll a 3? 1/6, right? And then we have to roll a 4. So the chance of that happening after we've rolled a 3, getting a 3 and then a 4, is going to be 1/6 times 1/6, which would be 1/36. If you think about it as a tree of all the possibilities, starting here, and then you could roll 6 different numbers, right? 1, 2, 3, 4, 5, 6. Now, if you had rolled a 1, you would have another 6 possibilities here of a 1, 2, 3, 4, 5, and 6. Same thing with 2. And now in 3, the same deal happens. But you want the 4. You want the 3 and the 4. But how many possibilities are there? You could do a 1 and a 1, a 1 and a 2, a 1 and a 3, 1 and a 4, 1 and a 5, 1 and a 6. So you have 6 possibilities here, 6 possibilities here, 6 here, 6 here, 6 here, 6 here. That's why the number of possibilities is, you have 6 in the first round. You're choosing one of them. And then from all those other rounds, you have 6 more possibilities. So it's got to be 36 overall possibilities, 6 times 6. And you only can have one outcome that you actually want, which is a 3 and a 4. The solution space. Don't know what that means. In this case. Yeah. Okay, sorry. I thought Roby was saying like this is the solution space because I always expect that little guy. I don't understand the face. You can't see the face, so it doesn't matter.
I can see the face.
You can't see the face.
Okay.
Oh, you can see the face. It's over there. I see it.
I can see the face.
I try to understand those faces.
Do they try to understand you?
Yes.
Very good.
No. Roby seems to say random things, but in this case, no. But terminology like that is not the most important for the SAT for this stuff. You don't need to know much terminology surrounding probability. I think these are the 2 most important things, or and then and. I mean, this gets significantly more complicated. There's not a ton of probability on either SAT or ACT. The ACT has a little bit more stuff with expected value, but this is the main stuff. And then there is the permutations and combinations. Would you like to talk about that? Was that you here in the moment that asked for these things? Yes, here in the moment. Would you like probability? So let me know here in the moment. Would you like to, sorry, did I say probability? I meant permutations and combinations. Yes, cool. Let's do that. So, Brady, you like starting with combinations, right?
Yeah.
I like starting with permutations.
Go for it, dude.
Okay. So, permutations. Let's start there.
Dude, I'm not going to stop you.
Don't stop. I'm going to do it.
I'm not, if you want me to stop you, I'm not going to do it.
Oh. Okay. So
I'm
let's
seriously
say...
I'm not going to stop you. I'm going to let you do this.
You're going to make
And
it
I'm
hard
not
for
gonna
me. That's all
interrupt
you're going to do.
I'm not going to stop you at all.
How about you and I describe permutations and combinations simultaneously?
That'd be wild.
Okay. Let's say you have these letters, which you do, A, B, C, D, and E. So you have 5 letters, and we're trying to order them in any way we can think of. So any order of these letters is totally fine with us. Okay? So we could do A, B, C, D, E. Let's start with A, B, C first, because we can actually list all of them. Now, this is an enormous amount of permutations and combinations stuff that I'm going to explain in a short period of time. So if you don't understand something, please let me know. This stuff takes a lot of practice, and you'll learn it in school eventually, and you will have a lot of practice then. Okay, so if these are our letters, A, B, and C, and we want to order them in all the ways we can think of. This marker is going to die. I don't know why this marker dies so fast. We could do A, B, C, of course. We could do A, C, B. We could do B, A, C. We could do B, C, A. And we could do C, A, B. And we could do C, B, A. Those are all the ways we can order all of these letters, if we're using all of them. Okay? There are 6 ways. This is technically called, this is a permutation question, okay? We care about the order. So permutations, well, what is the thing that you use to remember that permutations order matters and combinations?
Permutation sounds more complicated.
Okay. Order matters. Order matters for permutations. So this is written like this. What we have 3 things. So this is going to be 3 permute 3. Okay? That's how you write it. And the second 3, we have to write that because I'm going to move that down actually. The first 3 tells us how many items we have to play with, which is 3, of course. So that's the little 3 here, and then we have the P for permutations, and we're permuting all 3 of them. We could feasibly permute only 2 of them, which is a slightly different situation. So if we permute all 3, we've seen that we get 6. We listed all the ways. Now there is a faster way to do this, but we can just list them since we don't have too many. Let's say that we're only permuting 2 though. So we have 3 overall, A, B, and C, but we're only permuting 2. Which means we could have, I'm going to do this in blue now actually. And here in the moment, please let me know if something doesn't make sense to you here. If we're going to do 3P2, that means we're going to have, so not this anymore, we could do AB, we could do BA, we could do AC, we could do CA, we could do BC, and we could do CB. It actually ends up being the same number of things, which is, there is a reason for that that you could possibly think through later. It's not that important right now. In this case, we're only permuting 2 of them. We care about the order. AB and BA are different. Okay? Now, once we get up to the higher numbers, you can't write all these things out. That would be a waste. Okay? And it would take too long. You'd never actually finish. So there is a way to think about this that I like a lot more, which is, let's say we are going up to...
Ooh, Levi.
Yes, sir.
Permutation, position.
Permutation and position, combination, and...
It doesn't matter.
Caw.
It's just... And caw. Right?
Yeah.
Yes. But you have to think about positions with permutations.
Yes. Also, please ask us questions. I'm going through permutations and combinations now, but you can ask questions about anything you want. You can ask follow-up questions about this, whatever you want to do. But please let me know. Here in the moment, you're definitely here, I think. So please let me know if you want more of this, less of this, other things. I don't care. Secrets about Brady. I will tell you all of Brady's secrets because I
Don't tell him
know
about Soylent.
all of them. Excuse me?
Don't tell him about Soylent
I won't tell them about Soylent.
and the fact that I used to drink it.
It's the Soylent killer. It's the Soylent killer, my lord.
Soylent is the Soylent killer?
Soylent killer.
Ah.
All right. Let's add in more things. So A, B, C, D, E. If you're going to try to write all of these, so now we don't have 3 things, we have 6 things. I do not know what that means.
What?
Monka-esque? Yeah, I don't know what that. Can someone explain that to me? That's a gaming term thing, right? Or is that just a not old bozo thing?
Have you done anecdotals?
Hmm?
Have you done anecdotals?
No, but they're due tomorrow.
Today's Thursday,
When do they do?
10 p.m.
Oh. I thought they were due on Friday.
I thought that was the time card due on Friday.
You're right, but that's not even this Friday anyway.
Yeah.
Okay. Thank you. I put it in my calendar for tomorrow, actually.
I forgot, actually.
Yes, I did try Googling it and it didn't work. So I couldn't know. That's why I asked you. Okay, we're stepping up our game to 6 things. I do not want to write out A, B, C, D, E, A, B, C, D, or A, B, C, E, D, A, B, C. I don't want to say A, B, D, C. I don't want to do that. It's too much work, too many things. I don't want to write them all out. There are many ways to think about permuting things, and I want to talk about the one that I like the best that hopefully makes intuitive sense to you. Okay, I don't know what other people call this. I was taught this is called the dash method or the underlining method or whatever. So we have 6 spots to fill.
I like slots.
Slots?
Yeah.
We got slots.
But I think it is the dash method.
The dash method?
I call
Okay.
it a slot.
In the first slot, we could put an A, right? We could put a B, we could put a C, we could put a D, we could put an E. We have 5 options, right? We have 5 choices. Wait, where did I get 6 things? Roby, this is your job to correct me when I do ridiculous stuff like this. 6 things, okay? I don't really need to do this anymore anyway. But we got 5 things. We have 5 options here, right? Right now what we're doing is 5P5, okay? We want to figure out what that is. It's okay, Roby. Just, I'm not disappointed. I'm just mad. 5 options for that first slot. We can do any of these letters. Now, in the second slot, we've already chosen the first one, right? So we've taken one of these letters. We don't know which one it is. Thank you, Roby. Very good. What's the what in the hell for? Roby, what are you saying? Sorry, here in the moment. What are you saying that for? Did I not explain something, or I just did something dumb?
You Googled Monkus.
Oh.
Yeah, here in the moment said, when is X scared? Let me Google Monkus and see what this is.
I've heard it. I think it's called Monka-S. Not you. Not me. Very good. Okay, so here in the moment, make sure you understand this and not Monka-S because this is way more important. 5 things in the first slot. You have 5 options. But the second one, you've already taken one of the options, right? So now you only have 4 options, right? If you did C here, you can't do C. You have to choose from A, B, D, or E. Next slot, you only have 3 options, and then 2 options, and then 1 option, right? So the way to think about this is this is all going to be multiplied together. You have 5 options here, but then you have 5 choices for this first spot. And then, so this is like that tree that I drew before. You have 5 options. I should just draw this again. Starting here, you have 5 options of letters, right? And then let's say you choose A here. It doesn't really matter, but you chose one of them. Now you only have 4 options. You could do, you can't do A again, so now you have to do B, C, D, or E. And then let's say we take this one. Now we only have 3 options. We've done A, C. Now we can only do B, D, or E. And then so on and so forth. So every level, we have 5 options. Then each of those break into 4. And then each of those break into 3. Each of those break into 2. And each of those have only 1 letter left. So you don't really have a choice. You just have to do it. which means that at every level we have 5 choices, then all of them split into 4 more, or 4 separate choices, so now we have 5 times 4. So it's going to be 5 times 4 times 3 times 2 times 1. Here in the moment, have you studied this before, or no? Are you just letting me do this, but nobody actually needs this help? Or is this actually new or useful for you? Can you let me know? Don't just say yes or no, because I won't know what that means. So tell me, keep going, tell me stop. Either way.
They said yes.
Useless. Utterly.
You're doing great work.
Thank you. Ugh, Roby. Thank you. No, thank you. Doesn't look like we got anything from here in the moment. Who's probably still in the process of Googling.
It's like a emoji. It's like Pepe the Frog who's sweating and like nervous or something. It's not.
That's very exciting.
It's just an internet thing.
Yeah. Okay, I'm going to finish up. Okay, here in the moment is not here, so I don't know if it's even used. I'll finish this train of thought. So we're multiplying all these together. This, thank you. Thank you for what? Do you want more? I don't know what the thank you is for. Would you like... You're here. Very good. Do you want me to keep going on this?
Hey, that's my only body.
It's my only business partner.
Yep, and you broke it.
Moishe. Hey, give me Moishe.
You mean Moishword?
This is Moishe, everybody. In how many ways can you write a number as a product of increasing numbers?
7.
The answer is Moishe, my friend. 42. Okay. Here in the moment, you're not answering my question. Would you like me to keep going on this? 5 times 4 times 3 times 2 times 1. This is called factorial, okay? This concept. No thank you. Got it. We're done, Brady. Well, okay, so this just as a thing is 5 factorial. That equals 5 times 4 times 3 times 2 times 1. That's what 5 factorial is. All right. So, this seems to be fine. I'm going to erase this. Be sad I never got through it. I like doing it this way, Bird, because I always understood permutations as the factorial stuff, and then combinations as, okay, you have the factorial, but now in each piece of it, you no longer care about the order, so let's divide by that piece's factorial.
Yeah.
Like whatever's there, whatever's left over. And everybody should do it that way. Oh, dude, I have to tutor and do my anecdotes.
Jeez, man.
Yeah.
What time do you start tutoring?
9.
9?
Yeah.
Well, what does it say? How many viewers do we have on our restream?
No, I mean, I can do it while you're doing problems. That's what we did last week.
Yeah. I'm just going to say, we got 3 viewers on here. Not a lot.
Did anybody say anything for the Reddit post on the other tab there? Let's see. We need more questions. Here in the moment, what would you like to know? What other things? Since you didn't want to do more permutations, combinations stuff, which is on the test, just it's unusual. What other stuff do you want us to talk about? Give us some questions. We'll give you some answers.
Unfortunately not, Levi.
All right.
Oh, there's a new one.
I'm very hungry.
There is a new on the Reddit SAT page. New question. Looks kind of fun.
Oh, is there? How do you prep for the SAT? Watch this. SAT subject I'm in need of hope. Ooh. Stop it.
Sorry. I got scared.
I actually don't know.
What?
With this Reddit question?
Just put it up.
All right. All rise. Oh, this is pretty well cropped already. That's pretty cool.
Thank you. All right, what we got? What is this?
This seems open-ended, and it seems also impossible.
No, it's fine. The graph in the xy plane of the equation above is a circle. If the circle is translated downward a unit such that the circle is tangent to the x-axis, the equation becomes that. What is the value of a? Oh, we got this.
Yeah, I'm just not sure what the value of a would be.
Well, that's what they want us to figure out.
Yeah, but there's no other information. They said it translates down a units, and then they asked for the value of a.
Right, it's in the second equation.
Yes.
All right, so this gives us a circle that's centered at 6, 3 with a radius of 5. So 6, 3, here's the center. It's a radius of 5, so it's going to go over to here, and it's going to be 2 below. There's the circle. Okay.
It's a nice circle.
Thank you. Circle's translated downwards a unit such that the circle's tangent. So think about this. If you're going to make the circle tangent to the x-axis, you could either move it up so that the bottom is right there. You have to move it up, looks like about 2 units. Or you can move it down so that the top of the circle is then tangent to the x-axis. Sorry, Levi. So Levi's going to draw the circle. Look at that. Look at that. If that's the case, our circle has a radius of 5, which means the center needs to be 5 units now below the x-axis for that to be truly tangent to the x-axis. So if that's the case, this new y-coordinate is -5, whereas before it was 3. So what's happened here is that it was pulled down 8 units. And if that's the case, translate downward 8 units such that the circle plus 8 plus a. Okay, so -3. So the new formula has to be y plus, instead of y minus 3, it's now going to be y plus 5.
Yeah, and that equals y minus 3 plus a, and you can just solve for a.
Yeah, exactly. Yeah, equals y minus 3 plus a. Solve this thing. That's really tight.
That's
there.
fine.
Exactly. All right, so y's are gone. We have 5 is equal to -3 plus a. You add 3, and yeah, you get what we thought, a. Because it says it translates it downward a units, which is 8 units. A, 8, 8a.
Yeah, a and 8 are actually the same concept. They're spelled the same way.
A lot of people don't realize that. You know there's actually a way to spell letters? You didn't know that?
No, did you?
No.
Can't help you guys with that.
Yeah, sorry about that. Neither of us know.
I don't know how I skipped over that line with tangent to the x-axis.
Yeah, I don't know, man. Maybe you should pull up another question.
Yeah.
Here, I'll post this. Or you want to post it?
You can post it.
Okay.
This looks fun. If I gave my heart to you. Ooh, this is such a fun one. All right, here's the question. Please ask more. This is also soon after that last question.
Cool.
All right, so I'm going to ignore this for now, whatever. So we have 2 k 3k minus 3. So 2 to the 3k minus 3 power equals 64. This you can do a couple different ways. I recommend the change of base. Okay? Thank you for the warning. I actually did recognize that, but I appreciate it. I should need that. I shouldn't need that, but I do need it normally. Okay, so this is called change of base. Okay, you could do logs, but there's not too much need, and I think more important than logs is change of base concept understanding. So we have this base of 2. If we can get this down to a base of 2, we're fine. Like if we had something like 2, you can't see that, of course. If you have something like 2 to the x power equals 2 to the 4th power, of course you know that x is 4, right? They have to be. 2, they're identical except for this is an x, this is a 4, so x must be 4. If you have 2 equals 2 to the x minus 2 equals 2 to the 5th, then you know that the exponents have to be the same. So if you can get the bases to be identical, then the exponents must be equal, and you can change your equation. You can basically take the log base 2 of both sides. So you would get, this one would be x minus 2 equals 5, and then you just solve for x. Okay? So that's the goal here. What power of 2 gives us 64? That's what we're looking for. So left side is still the same, 2 to the 3k minus 3 equals 2 to some power. So let's think about this. We got 2, 4, 8, 16, 32, 64. So first power, second, third, fourth, fifth, sixth power. So it is 2 to the 6th power. Now, that tells us that 3k minus 3 equals not 2, nothing with 2. I'm going to erase this also. And this is probably misleading, so I'll just make it very hard to read and also ugly. So this is not a 2, right? That was the point. Not a 2. We have 3k minus 3. That will equal 6. Now we solve, so we add 3 to both sides. We get 3k equals 9. We get k equals 3. And now the question is, as Roby helped point out, 2k. What is 2k? Well, 2k equals 2 cubed, which is 8. So the answer would be 8. Yay.
Was it on the SAT Reddit that problem came?
Yes, it was. It was posted 27 minutes ago.
Okay.
Do we have more questions is the question.
No pictures of other questions right now.
Yes, my lord.
Absolutely, my lord.
Okay, let's do some more stuff. Let's see what we can find. I should probably make that go away. I don't know why it's so hard for people to post questions that are upright. I've never understood that.
Maybe it runs in the family.
Yeah, maybe. Okay, let's try the ACT. They send out ACT scores one day late and everyone on Reddit died over it. Yeah, man, it's awful. Yeah, is the ACT Reddit still just people posting scores and talking about it, or are there actual questions?
Someone's angry.
I'm not angry, I'm just angry.
Oh, well that makes
How do I know
sense.
D plus E? Add up to 180. Ooh, this is fun. This is not the nicest looking thing.
Why is this doing this?
Let me know if this is ugly, too ugly to read.
I can't. It won't refresh so that I can get like our video to like go to the current spot.
Yeah, because the new laptop is bad, or what?
No, it is something that happens on Twitch sometimes.
Okay. Yeah, I've had that issue too.
I think we got it actually.
Be nice, Roby. Okay, yes, it is a photo of a screen. You're right. In the following figure, line M and N are parallel. So the ones that look parallel are parallel. Great. Which of the answer choices does not necessarily add up to 180? Okay, so the question is, I think this person was not asking why is the answer K, because I think the answer is K. E plus G, they don't add up to 180. There's no reason they would. Why do D and E add up to 180? Is that really the question?
Yes.
Yes. Okay, cool. So, yes. So you were talking about J. Great, just making sure. So, if you have two angles and they add up to a straight angle like that, they will always add up to 180 degrees. Those are called supplementary angles. A lot of people forget that term. I actually have not seen that term on the SAT or ACT, but you definitely need to understand the concept. Are you asking me about Roby here in the moment? If that's the case, no, certainly not. And even if it is the case, if it's not the case, I also still don't know who Roby is. Aside from a sweet, sweet viewer. One of the many viewers we can hold in the palm of our hands. Oh.
This was on SAT, right?
This was on ACT. The current one?
Oh.
ACT.
Oh, wow.
Yeah, wow is right. Okay. Let us see if we can do anything else here. Lots of scores. You want to just share people's scores from Reddit? That sounds exciting. That'll be productive.
We love that. So are you done with that question now?
Yes.
Okay.
Yep, it's just a lot of scores. I'm glad people want to share. It's nice.
Thank you.
Your score is poop compared to people on Reddit. I mean, that's fine. Also, think about who's willing to post on Reddit. People with higher scores are more likely to post because they want the
adulation.
The adulation and the laud. The laud? No, laudatory is not the right word here. The allure. It's not right either. Validate. Yeah, all those words. Laudatory, but I just don't think it translates to this situation. That's what I was trying to do. Lauded?
Yeah.
They want to be lauded, yeah. But you can't say they want the acclaim or the aplomb. That's not really...
You can't say they want the aplomb.
They want the aplomb, dude.
Give them the aplomb then.
Dude, I wanted to be aplomb when I was younger.
Really?
Yeah. It's actually how I met my au pair.
Jesus.
Did you like that, Bert?
I did.
Okay, I'm glad. I thought it was awful. Okay, let's do more questions. So, here in the moment, what are your problem areas? Where do you find your problems? Oh. Law of cosines. All right, yeah, that can be hard. Law of cosines, I have not seen them not put the law of cosines up. So keep that in mind. A law of cosines is...
A law of cosines.
The
law of cosines. It's not a law, it's the law.
I didn't even say a law, I just said law of cosines.
Oh, maybe
Yeah.
you just said before it.
Yeah, law of cosines.
No, see, it's the law. You just did it again.
The law of cosines.
I don't appreciate the sass.
Oh, okay. C squared. Brady, say it with me.
C squared is equal to A squared plus B squared minus 2AB cosine
of
C.
C.
Yeah.
That's the formula for cosine. The law of cosines. The law of cosines. So, what do you want to talk about here? I know there are definitely questions on the ACT that I can picture right now on different ACT practice tests that deal with this. It's more about plugging in than anything else, and also understanding you just need to pay attention to this part. That side C, so sides are normally lowercase variables, angles are normally uppercase variables. So this side is opposite this angle. So if you're going to draw a triangle here, it does matter where everything is. So if this is side or angle C, then this must be side C, and then this could be A, it doesn't really matter. Side A, angle B, side B. Are you sure? Are you talking to me here in the moment? Is lowercase letters the sides? Yes. Normal. I mean, they don't have to be. You can call anything you want, whatever you want. But there are norms. This is the norm. And definitely for this, side C is opposite angle C. It must be. If it's not, you're not doing law of cosines correctly, and it is wrong. Or it is very likely to be wrong. I can give you, so let's say that, I mean, and then it's just a matter of plugging in. So as long as you know that these have to be opposite, then you can figure things out. So if you're given a random triangle, like that, and you know this side is 7 and this side is 12, and this angle here is, what does this look like, 110 degrees, something like that, you can now find this side here. Okay? So let's say this is x. You can't cosine a side. Yes, that is true, Roby. Yeah, you can't cosine a side. So, I mean, it doesn't matter what the letters are, as long as, you know, whatever this is in here is an angle, but this is the general formula. It's always written like this, and you can plug in whatever you want. So this is side x. I could call, you know, an angle lowercase w. It doesn't really matter, but it has to be cosine of an angle. Okay. Or you could say, as Roby said, yeah, angle BAC, something like that. Now in here, angle BAC is this angle here. Okay, so if you're doing this, and I'm saying, okay, find x using law of cosines, then you will do, you're going to plug in. And what you need to pay attention to is this angle and this side. That's what you're going to use for C and C, respectively. Okay? So it'll be c squared. You don't know what that is. It'll be x squared equals a squared, so it doesn't really matter. Let's say 7 squared plus 12 squared for those two, minus 2 times 7 times 12 times cosine of 110 degrees. And now you can plug all that in, and then you take the square root of both sides, and you can solve for x. If any other piece of this equation is missing and you have x instead, you just plug into the equation again. But you just need to remember that you're using x for C and 110 for big C, sorry, little c and big C. Otherwise, you can't use 7 and 110 because they're not opposite each other. So that is by far the most important thing with law of cosines, is C's are opposite, opposite angle and side. Okay, I've said that many times now, so I will let the, let the dead horse die, right, Brady? Hi, Yusufo.
No use beating a dead horse.
No use beating a lying dead horse?
Yeah.
You miss Brady teaching. I agree, because I'm tired of talking right now. Brady.
Yes.
Yusufo misses you.
Yusufo! Brady. I've never seen that before.
Oh gosh. Yusufo, I miss you learning from me. That's what I miss.
I'm going to go do my anecdotals. Have you done yours?
No, have you?
I haven't done yours, no.
No, yeah. I don't think we need to go this to 9. We only have like 3 viewers. Anyway, Usfo, how are you? I've never seen Brady before. Oh, Usfo wants a word of the day. Levi, you got one?
I do, my lord.
I've used my big 2, bolus and homunculus, so I'm out. Of course, I have 1 or 2 extra that are just kind of hiding up my sleeve. They're hiding up there.
Yeah.
Yeah, actually, they're hidden so well, I don't even know where they are anymore. I've tried setting up an expedition to find them, but couldn't find anything.
Got stuck in the ice, right?
Got stuck in the X? What? Very good.
Got stuck in the ice.
Yeah, they got stuck in the ice, exactly, yeah. And their boat just crumpled like a bunch of matches.
Yes, I do have a word, though.
Okay.
You like it. I was thinking about bolus. It's not that related. Gumption. I mean, it's not related at all. It's just the sounds.
Yeah, no, I get that. As in, you got a lot of gumption, kid.
You got a lot of grit,
A lot of gump shin. Your
Yes.
shin's got gump on it.
So this is initiative.
Yes.
And,
you want to try spelling that again?
No.
Initiative?
Yeah.
There's also another T in there. There's a lot of things wrong with that. No, you have to erase more of it.
I know. I can't talk and write at the same time.
Initiative.
Initiative.
Oh, is that one of those H's with a dot?
Yes.
Okay, gotcha.
That's how you make the sh sound.
Oh, I didn't realize that.
Yeah. You spit on your business partner.
I could unironically use more gumption in my life. Everybody can use more gumption.
Yeah, but only unironically.
Yeah. There is a distinct lack of gumption in today's society.
You know what helped?
What?
I don't know, but it wasn't that.
What? You had an H with a dot.
No, I didn't.
Yes, you did. You had this. As though that's T-I. I don't even know, that's a chair with a thing floating on top of it. Maybe they took a snapshot as this thing fell.
Look, that looks like a minimalist logo design. That's what it looks like.
Logword.
Logword.
No, it wasn't meant to be with the
Oh,
the
it wasn't?
tones. No!
What was that?
Look what he did to me, Mom! If you're watching, it's your gumption that gets you streaming every night. That's right.
Yes.
We're just channeling our gumption.
It's
right
actually
into
the
your
enormous
eyes.
amount of money we're making right now from you.
Please tell your friends about us.
Yeah.
Yeah.
Please ask us questions.
Yes. We're about to just unleash a torrent of great Instagram videos. Actually, though, very, very soon. So
Yes.
follow us on Instagram. Follow us on Instagram.
Follow us.
I think it'll be good. I think it'll be good if you follow us on Instagram.
Gumption is like initiative, drive. It's not grit so much. So it's like
Sorry. That was useless. That's the problem. Is I want a certain sound, but the letters aren't going to be right. There. Gumshword.
Gumpshword.
Yeah. I have a cousin named Gumshword. Did you watch that Instagram's page? I installed Instagram because it's toxic. It is toxic except for Nerdish's Instagram page. Did you watch that IG's page? What does that mean? Did you watch that IG's page? Oh, Roby Expert. Yes, yeah. I checked it out a little bit. Yeah, it's the guy that streams math. He's got his head in the corner, kind of like a video gamer, and then most of the screen is his like tablet to write on. Roby Expert, thank you for watching that. Yes, I found that very interesting.
Want to try to explain number 10? It's math 2.
Yeah, I can.
Okay. I just found it.
Roby Expert, we have to take another look at that because I looked at it during the stream and then Levi was just distracting me afterward.
What?
Because he's my business partner.
I am your business partner.
You're my business partner, my partner in business today. You gotta do your anecdotes, man.
Yeah, that's very true. This is one of those dark questions.
That's fine. All right, get out of here. Starting it. Wait, you have the answers up.
Oh. Thought it was, okay, I didn't really read it.
Great.
This is honestly a disaster.
It feels that way.
Done a better crop job too. There we go.
Are those on scheduler, right?
There you go. Yes. For which of the following functions does f of xy equal negative f of negative x negative y for all values of x and y? Oh, that's very interesting. So that is a multivariable function. It's a function that takes in an x and a y. Do you watch The Good Place? I do. I haven't seen the new season though. I'm still working my way through another show, but Good Place is up next on my docket of shows to watch. Usfo, do you watch it? How far are you in there? Don't ruin anything, please. It's a function that takes in two variables and then does something to it. We don't know what it is. New season episode 1 is today. Is today? Oh my gosh. Oh, that's when they release. I thought they already released the new season. Is it just live today for the first time on TV? Anyway, we want a function that if you were to take the negatives of the x and y, but then take the negative of the function, you'd get back to the original function, which is the definition of an odd function, actually. So f of x is equal to f of negative x. This is an even function. And an even function is symmetrical across the y-axis. So y is equal to x squared. You could put negatives into x, and you're going to get the same answer. Negative 3 and positive 3, they're both going to give you 9. So you have this symmetry. It's fantastic. Then you have an odd function. An odd function, like y equals x cubed. The rule for an odd function is f of x is equal to negative f of negative x. So what this is doing is the negative x flips something across the y-axis. So it flips it sideways, and then the negative in front makes it go downward or upward. It flips it vertically. So this here, if you flip this thing sideways, first it's going to look like this, and then if you flip that downward, it'll turn back into its original function, which is what an odd function does. So the reason why I'm saying that is because this function looks like it's going to be odd. No, like season 3 recently came out on Netflix, but it's been out for like a year. Season 4 is brand new and airing live tonight for the first time. Oh, geez. All right, so I got to watch season 3 still. And then people are going to start talking about season 4. I'm going to be left behind, and then Usfo is going to know everything. Don't tell anyone, Usfo. Don't tell anyone else, because then people are going to start watching it. So, anyway, this is going to be fun. We want it to be an odd function. Well, what that's going to mean here is that anything with an even exponent is going to be wrong. Because if you have an even exponent, that's going to take a value, and it's going to be more like this, like y equals x squared. That takes a negative value, but when it squares it, it turns it back into its original positive value. So like here's one example. So like let's start with a. F of xy is equal to, so if I put negative x plus negative y squared, what they're saying is that they want it to be equal. Oh, you know what? I have to take the negative of that function as well. They want this whole function to be, the negative of that to be equal to the original function. So just f of xy, which in this case is x plus y squared. So if these two things are equal, then we are in business, x plus y squared. So this is going to be negative x plus y squared, but there's a negative in front of it, which is going to flip these signs, x minus y squared. X minus y squared does not equal x plus y squared, so that thing right there is not going to be equivalent. I'm having kind of fun with these. So let's go to b. So we have x minus y squared. According to the function, should be equal to the negative of, so we have negative x minus negative y squared. And this is going to be negative x minus y squared equal positive x plus y squared. But it's supposed to be x minus y squared. You see what's happening here. What about e to the x? Specifically, what about e to the x? It's not an odd function, nor is it an even function. It is its own function. It's a pretty fascinating function because it is its own derivative, and it's also its own integral, which is kind of mind-boggling if you allow your mind to become boggled in that aspect. So what I'm going to guess here is because it's an odd function, it's going to be d because it has only odd exponents, 1 and 3. So I'm going to try that, and we're going to see if it works. So x plus y cubed.
we should get the same thing if we take the negative of negative x plus negative y cubed. That's not a great 3, sorry. Sorry, everyone. All right, so this is going to become negative x plus. Now, negative y cubed is going to turn back into negative y, so that's fun. Which means, oh, this is also negative. Equals, so this is going to be negative of negative x minus y. Sorry, it's cubed. I don't know why I screwed that up again. Negative y cubed. So now it's minus y cubed. And then you apply the negative, and you get equals x plus y cubed, which is equivalent to its original function, which is d. So that is the right answer for this. I hope everyone enjoyed that journey as much as I did, especially Usfo. Usfo, you missed me teaching. I missed you learning. Because I wake up really late at night and just wonder if Usfo's learning and if there's anything I can do to make that happen to a greater extent than what is happening. We did enjoy. Very good. That's thoroughly excellent. Thoroughly excellent. All right, Levi, what time we got?
We have 8:34.
8:34. We've done an hour. Not a lot of viewers. Is there anyone else that has a question? Anyone else? Question for stream? Question about Levi? Question about Brady? Question about Brady's relationship to Levi? Question about Levi's relationship to Brady? Question about comparing and contrasting their respective relationships to the other. Those are kind of your subjects here. Because if not, I think Levi and I will. Are complex numbers on the SAT? Usfeld's a great question. Yes, they are. Would you like to talk about them? The ins, the outs, the complexities? They are on the SAT. They do show up on the ACT as well. Do you want to talk about complex numbers, Mr. Powers? The laser.
Do you want to talk about complex numbers, Mr. Powers?
You want to talk about complex numbers, Mr. Powers? It's Austin Powers. Just a fun little thing we used to talk about when we were young. Usfo, I need an answer from you. Do you want to talk about them, or are you good with them? You're just wondering. Do you know how to add them, subtract them, multiply them, divide them, place them on the complex plane, take powers of I, take the absolute value of them? Do you know all those things? Can you give us an easy way to conceptualize the complex plane? Oh, absolutely. You know what the easy way to conceptualize the complex plane is? The complex plane itself. It's not as hard as you think. Not as hard as you think. So the reason why we have complex numbers in the first place is because, okay, complex number has two parts to it, a real and an imaginary. That's why we call it complex, because it's got two things. It's not just one kind of number. So for instance, 3 plus I is a complex number because it has a real component and it also has an imaginary component. The imaginary deals with I. I'm going to make it a little more complicated, actually. 3 plus 4i. 3 plus 4i. Okay? So the complex plane is a place to visualize where these points are. Or just a way to, way to visualize where they are. There's actually a really cool way to think about imaginary numbers, which I can show you in a sec. But the way that the complex plane works is it's got an x and a y axis, except we don't call them x and y. They just look like x and y. I'm going to draw it in a sec after I'm finished erasing all of these blobs. There we go. So, complex plane. The x-axis is the real axis. That's where we graph the real component. And the y-axis is the imaginary axis, where we graph the imaginary components. So, this looks just like a normal x-axis. You see numbers, it's all good time. You got the origin, -2, -3, -4. And then you're counting in i's on this axis. I, 2i, 3i, 4i. And you're going downward as well. -I, -2i, -3i. So the point 3 plus 4i has an x value of 3 and a y value of 4i, which means we just go to that place.
That right there is the point 3 plus 4i.
It's right there on that plane. What do you think about that, Usfo? What are your thoughts?
So it's just like x and y. That's really all it turns into. We had like 3 minus, no, I'm sick of using, let's go negative 3 minus 4i. I'm bad at I gotta use different numbers here. You go to negative 3, then you go down to negative 2i. That's that right there. Negative 3 minus 2i, 3 plus 4i.
3 plus 4i. Now, as far as like, what does this allow us to do? There's a couple things. I get that way of plotting complex, but I don't understand how this complex axis relates to real space. Oh, Usvo, you have no idea how happy that question makes me. Okay. So I've watched this YouTube series, which I highly recommend, called Imaginary Numbers Are Real, that I think you should watch. It's got a fair number of parts, but they go into detail about like what the whole point is of complex, or really imaginary numbers, and then complex as well. So imagine this, a number line. Here's 0, and I'm going to give some numbers. 1, negative 1, 2, negative 2. Make this a little longer. We got 3, we got 4. Okay, so the idea of, let's say, 2 plus 1 means that we're starting at 2, and this is very rudimentary. Adding 1 means we're shifting our dot 1 to the right, and it ends at 3, which that's pretty easy. Okay. Now let's go to this. 2 times 2. You could think of this as a stretch. We're taking this line, and every point is going to become twice as large as it is. So 2 is going to go to 4, 1 is going to go to 2, and 3 is going to go all the way to 6. And 0 is going to stay at 0, 1/2 is going to go to 1. So you see all of these things are getting bigger by a factor of 2. All right, this 3 used to be 3 units away, and now it's becoming 6 units away. All right, so there's a great way of animating this, but it's like all of these things kind of get picked up and then stretch that way. Follow, good. Okay, now let's think about this. 2 times, we'll say, negative 2. This sends it to negative 4. So the way that you should think about this, first off, the stretching still applies, but it also rotates. Negative 3, negative 4. To get to negative 4, every dot basically has to rotate to its new spot. So you can imagine this thing rotating and then doing the stretch. Or you could have it do the stretch and then rotate. But yeah, so this becomes negative 4. 1 becomes negative 2. Negative 3, if you multiply it by negative 2, it's going to become negative 6, which is all the way over here. It's all these rotations that are happening. All right, and if you're negative, like we had here, like negative 3, when you rotate it becomes positive. So these are like, multiplying by a negative number is like a 180-degree rotation. How are you on that so far? You still good? Because it's about to get wicked and wild. Wicked and wild. All good. Very good. All right. So now let's think about, I'm just going to use small numbers because I have a small number line here, but let's think about the square root of 4. Square root of 4 is 2, but it's also negative 2. Okay, let's imagine both of those things. You're at 2, so you've got, this is your length, and you're going to become stretched. Now you're twice as long, you're at 4. All right, if you're negative 2, so 2 gets multiplied by 2, negative 2 gets multiplied by negative 2. So you were here before. Here's negative 2. So this thing, because it's being multiplied by itself and negative, oh geez, I'm sorry, this is 0 right here. This thing rotates around and goes to negative 4. Okay, same deal. But the question then becomes, how do we get to a negative number? How do we take the square root of negative 4? We can't get there. You take a negative number multiplied by itself, it becomes positive. You take a positive number multiplied by itself, it stays positive. That is the hard part here. I'm going to give myself a new number line. So thinking about it in terms of rotations is going to make this next part make more sense, because you probably never thought about multiplying by a negative number as a rotation along the number line before. I'd never thought of it like that until I got really into watching math videos on YouTube. I really like this stuff. It's really good. Where's Rachel? Where is she? Where is Rachel? Okay, no, I'm not. LOL. Yeah. Okay. Okay. So multiplying by a number is like stretching the number line. Multiplying by a negative number is rotating it to the other side, and then also doing the stretch if that's what you're going to do. So. Here we go. New number line. We have 0. And I'm going to give us, yeah, you know, let's just do the 4s again. So we have 2, 4, 6, -2, -4, and -6. So the question is, what number multiplied by itself is going to somehow end at -4? How do we do that? Everything that you multiply by itself somehow gets to +4, or 2 and -2 go to +4. So here's what they decided to do, or how they decided to visualize it. What if a number was perpendicular to this real number line? So what if we had a new kind of number that we put here? Okay? And if you multiply by this number, that's associated with a 90-degree rotation, a half rotation. Exactly. Or really a quarter of a rotation as opposed to, a half rotation. Multiplying by I is a 90-degree rotation. Multiplying by I again is another 90-degree rotation that leaves you here on the opposite side of this real axis. So what I mean by that is if you take 1 and you multiply it by I, you're starting here at 1. You multiply by I, that is a 90-degree rotation. So where that's going to leave you, there's 1, is right here, which is 1I. If you multiply by I again, that is going to bring you another 90-degree rotation around, which drops you off at -1. So 1 times I is just I squared, which is -1. So any number multiplied by I is rotated by 90 degrees. Not all the way, okay? I squared, so I, which is already 90 degrees rotated, times another I, is going to bring you to -1. That's what the half rotation is. And that's what happens on the complex plane. So multiplying by I gives you a 90-degree rotation. I kept saying that. But like here is, you might have seen this before, where they show you all the different powers of I and how they continue to repeat. So this is -I, and then I to the 4th is 1. So if we just zoom in here, if this is 1, this is I, this is -I, and then this is -1. I to the 1st, which is just itself, is just I. So we start here. If you rotate 90 degrees, you are at, I'm sorry, this is -1. That's supposed to be -1. If you rotate 90 degrees, you are at -1. So that right there is I squared. And then you rotate again, I cubed is -1, I to the 4th is 1. Multiply by another I, which is I to the 5th, you get back to I. And you keep multiplying by I, you just keep rotating, and you keep finding yourself at these 4 values. 1, I, -1, and -I. Was that why imaginary numbers were originally conceptualized? Imaginary numbers were originally conceptualized as kind of a shortcut because mathematicians didn't really know what to do with the square root of a negative number. They didn't know what to do with it. So they just said, all right, let's just, instead of continually writing square root of -1, so like if they said, we're trying to take the square root of -25. So, okay, we know how to take the square root of 25. So if we break this up, we have the square root of -1 times 25. This part we can do. That's 5. This part, let's just call that something, and we'll all agree on what that means. I. 5I. Sure. And then, I don't know if they conceived of that as rotation then. I'd have to watch you probably should watch those videos because they're super cool. But something to notice is like, let's take 3 plus 4I and let's multiply it by I. So 3 plus 4I times I is going to give you 3I plus 4I squared, which is going to be, that's going to be -4 plus 3I. And if you plot that, -4 plus 3I is right here. Guess what you just did? You just rotated 90 degrees. This was your first position, and then you rotated 90 degrees. This is your new position. All right? That right there was your rotation. So with complex numbers on the plane, can you link the videos for me to watch later? I'll just, yeah, I mean, I can. On YouTube, though, just look up imaginary numbers are real. That's all you need to look up. They make the case that calling them imaginary means that, like, they don't exist. They're kind of made up, but that's not exactly true. It's probably the wrong way to call them. It's a really cool series because it, like, visualizes, you know, there's a lot of polynomials that, like, you know, got, like, you know, if you have a parabola, like x squared plus 3, it never crosses the x-axis, so you have no real roots, because roots are intercepts. Well, so that's the one. Yeah. You got no real roots. So the roots end up being, let's see, you have negative 3, square root of negative 3, plus or minus 3i. There's a way that they show you kind of how to visualize it, which is they bring the complex plane into play. And you see the parabola becoming three-dimensional, and you have to watch a couple of videos to get to the point where they explain that, but you see that it does in fact cross the x-axis if you factor in imaginary numbers. Super cool. Yeah. I think some of the videos, like the speaker is a little, it's like a little slow paced, so if you want to just like knock that speed up to like 1.25 or something. Yeah, no, I was very thoroughly impressed by that series of videos. They do a very good job of explaining all of it. But hopefully that cleared some things up. You will see a lot of what I just talked about and plenty more, and the history also explained if and when you watch those videos. Anyway, yeah, cool. All right, I'm glad. Yeah, this is my eye lab. That's where I work on eyes, eyeballs. That's good. That's good. What was I gonna say? There's. So wait, I was thinking about this the other day. Square root. Oh yeah. Okay. Yeah. One last thing I was thinking about. So like, let's say we wanted like the square root of negative 4. We kind of never really fully finished that. So the square root of negative 4 would be plus or minus 2i, and so 2i is right here, and then negative 2i is right here. Okay, so if you multiply by 2i, that's going to give you a 9-degree rotation, which is going to bring you, yes, so the 2 is also going to stretch it, and then it's going to give you that 9-degree rotation. So it's going to end up here, all right? And then negative 2i times negative 2i is going to become positive 4i squared, but multiplying it by this is going to be a 3/4 rotation. Because multiplying by negative 2 is going to flip it over itself, because like a negative multiplication flips the axis, but you still have to multiply by I, which is one more 9-degree rotation. So it's got this 180 built in, and then an additional 90, which means that this thing is going to make itself go 270 degrees. That's why both of these end up going to negative 4. There's 2 roots for square root of negative 4. Super wild. All right, I'm gonna clean this off. Yeah, pretty exciting. Pretty exciting. Everybody's having fun. Do you need to know it to this extent for the ACT and SAT? Absolutely not. Does it give you a little bit more context? Hope so. Yeah, no, it totally does. Yeah, for me, it's like math makes sense if I know what to visualize. There are points in later, higher levels of math where I sort of stopped seeing what was going on. And that's actually because there are ways to visualize them that I just wasn't really told about. Had I known those, it would have made a little more sense. But yeah, you can see it. It makes a big difference. Levi, what time is it?
52.
All right. Uspo, you got anything else? We got a good vibe going on between you and me. Between you and me?
Yep.
Good. All right. You know, visualize a... No, I do not. Yeah, I do not. Is that multivariable calc? Because if so, I'm pretty sure it is. If so, talk to me in like a month or so. I'm working my way through multivariable calc again. But actually, if you are interested, this YouTuber, 3 Blue 1 Brown, has the most gorgeous math videos I've ever seen. And he's got a whole chapter of videos on calculus, and there's some three-dimensional stuff there as well. I would not be surprised if there's something in there about how to visualize a, I don't know if it's Laplace. I'm guessing it's not Laplace because that sounds like I am American. Laplace transform. That guy seriously has some sleek videos. His voice is very pleasing too. He's doing good stuff. All right, unless there's anything else, I think we're gonna probably retire for the night. Levi, got anything?
No, sir.
Very good. It's been wonderful to serve as your guide through the ins and outs of the complex plane.
Good night, everybody.
Good night. We are nerdish. Bum.